Hello guys, I am Charan and my teammates are Ashwath and Eshan. We are from BMS College of Engineering and today we will dive into the one of the coolest natural inspired optimization technique that is bee colony optimization, which is also called BCO. Just like honey bees search for food efficiently, these algorithms solve complex optimization problems in AI, robotics, scheduling, and more. And move on. First is what is bee colony optimization? Bee colony optimization is a meta heuristic algorithm inspired by forecasting behavior of foraging behavior of honeybees. In nature, bee finds a best food source by exploring, sharing information, and exploiting goods location. And BCO used this idea to find the best solution among many possibilities. It's widely used in machine learning, routing, resource allocation, and engineering optimization. The question is why bees? Bees naturally perform optimization every day. That is, they explore random location for nectars and they return to the hive and share information. And other bees follow the best dancing. Together, they pick highest quality food source. This collective intelligence is exactly what DCO tries to simulate. And here is the key features in BCO that are nectar exploration. First, the process where bees search for flowers to collect the nectars and which is used for making the honey. And next one is waggle dance, which is a specific pattern used by bees to communicate the direction and distance of the food source to the other bees. And third one is good food foraging, the act of bees collecting food, particularly nectar and pollen from plants to bring back to their hive. And fourth one is division of bees, the social organization of bee colony into different rules such as workers, drones, and queen, each with distinct responsibilities. And fifth one and last one is meeting during the flight. The process where queen bees meets with drones in mid-air during her nuptial flight to collect sperm from future fertilization. And next is how BCO works. Let's break the algorithm into simple steps such as first in initialization, a set of bees is created and each bees represents a solution. For example, if we are finding the shortest path, each bee holds a possible path. And next is forward pass. Each bee independently explores a new solution by making small changes in its current one. And backward pass. Bees return to the hive and publish their findings. If the solution is good, they perform dance. Other bees decide whether to follow them or keep exploring. Next is recruitment. In recruitment, more bees join and refine the best performing solution. And last one is iteration. This step repeats until the algorithm converges to the best solution. For example, to understand, imagine we want to assign exam schedule to avoid clashes. Each base tries different combinations of timings. The best combination attract more bees. Gradually, the colony converges towards the schedule which minimizes the conflicts. And next part will be explained by Eshan Gowda.
So next part is ABC pseudocode. So this slide shows the ABC, that is artificial bee colony algorithm, which works in multiple phases inspired by behavior of honeybees. So first step is initialization phase. We start by generating a set of random solutions called food sources. So second step is repeat loop. All the next phases keep repeating until the stopping condition is true. So third step is employee B phase. Each employed bee explores a new solution around its current food source and keeps it if it is better. Next phase is onlooker bee phase. Onlooker bees watch quality of food sources and selects the best ones based on the probability. And the next step is scout bee phase. If a food source doesn't improve for many cycles, it is abandoned and replaced with the new random one. And the next step is memory-based solution. The algorithm always stores the best solution around found so far. The last step is until stopping criteria. The process continues until a condition is met, like maximum iterations or no further improvement. So next slide is employee B phase algorithm. So employee bee phase algorithm is a part of artificial bee colony algorithm used in optimization problems. It mimics the foraging behavior of honeybees seeking optimal food sources. So first step in this algorithm is, so an employed bee is linked to a specific food source xi. Next second step is select a random food source xk. K, K is an index randomly chosen representing another food source not equal to I. This introduces diversity and helps the bees explore new solutions. So third step is generate a neighbor solution, that is Vi. The new candidate solution is given by the equation Vij is equals to Xij plus 5ij into Xij minus Xkj, where Vij is jth component of new solution for food source I, Xij is jth component of the current solution assigned to Bi, Xkj is jth component of another randomly chosen solution, that is Bk, 5ij is a random number uniformly distributed in the range -1 to 1. This operation lets bees to explore the neighborhood, increasing the chance of finding better solutions. Next, fourth step, greedy selection. The fitness function of Vi and Xi are compared. If Vi yields a better fitness value, it's accepted. Otherwise, B retains the original one, that is Xi. This step ensures only better solutions survive to the next iteration. So next is onlooker B phase algorithm. So this step includes choosing and exploit the best food sources based on their fitness probability, promoting promising candidates. So let us see the algorithm. So first step includes calculate the selection probability for each food source. Probability expression is Pi is equals to, so fitness value of source I divided by total fitness values across all the sources. So this selection is done by roulette wheels selection. Each onlooker B selects a source based on these probabilities. Higher fitness gets more attention. Second step is for selected food source, generate a new neighbor solution that is given by the equation Vij is equals to Xij plus 5ij into Xij minus Xkj. So evaluate the fitness, assess the quality of the new solution. Same as in the employed B phase, choose the better solution between the current and the candidate, keeping only improvements. This step collectively help the ABC algorithm, that is artificial bee colony algorithm, balance exploration and exploitation, driving a global optimization for complex problems. So next is Scout bee phase algorithm. So, Scout bee phase algorithm and onlooker bee phase algorithm covering. So okay, explore this step explores new areas in search space by replacing stagnant, that is abundant, food sources. So first step is for each food source, track the trial counter. That is, if the trial counter exceeds the limit, it means this food source hasn't improved for the number of attempts, so it gets abundant. Trial counter, an integer associated with each food source, incremented each time solution does not improve. Second step, replace with a new random food source. So expression is given by, so xj is equals to xj of minimum plus random, any random number between 0 and 1 into xj max minus xj minimum. So xj is equals to jth variable of new food source. Xj minimum means minimum value allowed for variable j. Xj max means maximum value allowed for variable j. So random of 0, 1, a random number, as I said, a random number between 0 and 1 ensures diversity in new solutions. This resets the abundant source to a random position within allowable bounds to explore different regions of the search space. Abundant and reset ensures stagnant solutions do not waste further search effort. Third step is reset its trial counter to 0. So this step prepares the new solution to start fresh within the algorithm's operations. So next further slides will be continued by Ashwath.
Hello guys, now I will be explaining the flowchart of the bee colony optimization. First it will start by initializing the food sources. Next phase will be the employed bee phase. In employed bee phase, each employed bee is assigned to one food sources. They search around the current food source to create a new candidate solution. Then they compare the new solution with the old one. If the new one is better, then the bee updates the food source position. Mainly this phase focuses on improving current solution. Then next phase will be the onlooker bee phase. In onlooker bee phase, onlooker bees waits out inside the hive and decide which food source to work on. How they will choose? They use roulette wheel selection, meaning food sources with better quality have a higher chance of being selected. What they will actually do is once they select a food source, they generate a new candidate solutions around it. If the new solution is better, the food source is updated again. This phase mainly improves the most promising solution. Then next phase is the scout bee phase. In scout bee phase, if a food source does not improve for a long time, it is marked as inactive. What happens here is the bee becomes a scout bee. It abandons the old food source. It generates the complex. It generates a completely new random food source. This phase helps the algorithm escape local optima and explore the new areas. Then coming to the last, we need to check for the terminal condition. If after all three phases, the algorithm checks as the maximum cycle number, that is MCN, been reached. If no, we need to repeat all the steps again. If yes, we will stop the algorithm. At the end, the best food source found during the iterations is selected as the best solution. Then coming to the next slide, which is the advantages of the BCO. BCO advantages, it is simple and easy to implement. The algorithm is straightforward and beginner friendly. Then it works well for complex nonlinear problems, useful when mathematical optimization methods fail, and it is a good balance between the exploration and exploitation. Exploration meaning finding new areas. Exploitation means improving existing solutions. Then naturally parallel, which means many B means agents search at the same time, speeds up solving. Then the limitations of the BCO. It may be slow for very large problems because many iterations are needed to find the optimal result. The second one is the risk of getting stuck in local optima. Sometimes bees improve a bad solution and stop exploring better ones. And it requires parameter tuning, which means you must adjust values like colony size, limit value, recruitment rate, etc. Then coming to next slide, which is the applications of the BCO. Applications in the real world, we use it in traveling salesman problems, finding the shortest route to visit multiple cities. Then vehicle routing and logistics, which means optimizing delivery routes for trucks, buses, couriers. Then next one is robot path planning, helping robots to find the best path while avoiding the obstacles. Then next is the production and job scheduling, assigning a task to machines in factories for minimum time or cost. Then wireless sensor network optimization, deciding where sensors should be placed for best coverage. Then at last, feature selection in machine learning, selecting the most important features to improve the model performance. So this is our presentation. Thank you.